You've probably seen those amazing images from the James Webb Space Telescope, stunning views of deep space that really make us wonder what's out there. But now, something just as exciting is happening right here on Earth. A powerful new ground-based observatory has started taking pictures that are just as incredible. Then, you already know how excited we are about the Vera C. Rubin Observatory. It's located high up on Cerro Pachón, a mountain in Chile, and it's just taken its very first images using the biggest digital camera ever made. This camera is massive, about the size of a small car, and weighing nearly 2,800 kilograms. It captures photos with a mind-blowing resolution of 3.2 billion pixels. To help you picture that, it would take around 385 4K TVs to show just one of its full images. That's an insane amount of detail. Each night, the observatory is capable of gathering up to 20 terabytes of data. Since it's based in Chile, but the data needs to get to the United States for processing, a super-fast 100 gigabit internet link was built to send everything to Miami, Florida, where it connects with the rest of the network. The very first official images were released in June 2025, and honestly, they're some of the most stunning space photos we've ever seen. And the best part? This is only the beginning. So what exactly do these first images show? How are they taken? And what kind of discoveries are scientists hoping to make in the coming years? Even though some systems are already up and running, final testing of the whole observatory should be done by the end of 2025. And just like it's expected to make history in the field of astronomy, the observatory is named after someone who made history herself. Back in the 1960s, when women were rarely recognized in the field, Dr. Vera Rubin made one of the most important discoveries in astrophysics, strong evidence for the existence of dark matter. And she did all of this while also raising a family. It's only right that such a groundbreaking project carries her name. And just like Dr. Rubin, this observatory is set to make a huge impact. One of the reasons images from telescopes like Hubble and James Webb are so sharp is because they're in space, far from Earth's atmosphere, so they avoid interference from weather and light pollution. That's exactly why the Rubin Observatory was placed high in Chile's Atacama Desert. Its location gives it some of the clearest, darkest skies on the planet, perfect for observing the universe. It's not alone out there either. That region is also home to other major observatories like the Gemini South Observatory, the Southern Astrophysical Research Telescope, the Giant Magellan Telescope, and the European Extremely Large Telescope. Over and over again, this area has proven to be one of the best spots on Earth for looking deep into space.
What's interesting about the Rubin Observatory is that it's not operated by big space agencies like NASA or ESO. Instead, it's funded by the U.S. National Science Foundation and the Department of Energy, and managed by the Association of Universities for Research in Astronomy. Inside the observatory is the Simony Survey Telescope, which became the 7th largest telescope in the world when it was finished. The main mirror of the telescope is 8.4 meters wide and has a secondary mirror that's 3.5 meters across. But what really makes this telescope special is its third mirror, which is 5 meters wide. Most telescopes use 2 mirrors to focus light and fix any distortions caused by the mirror's shape. But the Simony Survey Telescope uses 3 mirrors, giving it a much clearer and sharper view. Attached to this powerful telescope is a camera that's just as impressive. It's the biggest camera ever built, about 3 meters long and 1.6 meters wide. This camera is designed to capture light in ultraviolet, visible, and near-infrared wavelengths. It uses a robotic arm to move filters in front of its sensors. The camera is named after the Legacy Survey of Space and Time, a project that will use it to carry out a sky survey lasting 10 years. The camera has 189 sensors and includes 3 large fused silica lenses. Each picture taken covers 10 square degrees of the sky, meaning it can see a very wide area. To give you an idea, one image can capture an area of the sky equal to about 45 full moons. If we compare this to older surveys like the Sloan Digital Sky Survey, SDSS, the LSST can do in just 3 days what took SDSS 20 years. SDSS mapped 35% of the sky during its 2 decades, but the LSST can scan half of the sky visible from the southern hemisphere every 3 days. The 10-year plan isn't just about covering more sky, but also about watching how things change over time, making a kind of time-lapse movie of the universe. Like other sky surveys, the LSST looks for all kinds of objects and events in space. It has 4 main science goals: studying dark matter and dark energy, listing objects in our solar system like asteroids and comets, tracking sudden events like supernovae and gamma ray bursts, and mapping stars in our Milky Way. Previous surveys like Gaia, Pan-STARRS, DESI, and Sloan laid the groundwork, but Rubin is taking it much further. For example, it's expected to find millions of new asteroids, greatly expanding what we know about objects near Earth and beyond. And the best part is, we don't have to wait the full 10 years to see results. The LSST team will share images regularly as the project goes on, so everyone can watch new discoveries happen. The first pictures were released in June 2025, and after just over 10 hours of testing, the Rubin Observatory had already captured cosmic events on an incredible scale. Millions of stars and galaxies, along with thousands of asteroids. What you're seeing now is just a tiny glimpse of what's coming from the Rubin Observatory. This is one of the very first images released, called the Cosmic Treasure Chest, and it's made up of 1,185 pictures taken over 7 nights, and shows a part of the southern Virgo cluster, which is about 55 million light-years away.
The Virgo cluster is the closest big group of galaxies to our own. This 25 square degree mosaic reveals an incredible mix of stars and galaxies. It's created by combining multiple photos of the same area, each taken at different times and through different filters, to bring out faint details that might otherwise be missed. Let's zoom in on some interesting parts. In the upper left corner, 2 large spiral galaxies stand out, with 3 merging galaxies just above them. You can see thin strands of material stretching between these galaxies. Both nearby and far-away groups of galaxies fill the image, along with some stars from our own Milky Way in the foreground. On the other side of the picture is a lively section called Cosmic Drama. Here, bright stars from our galaxy shine in front, with many nearby galaxies clearly visible, and a distant background filled with red-tinted galaxies. This image includes about 10 million galaxies, but that's only 0.05% of the 20 billion galaxies the Rubin Observatory aims to study over the next 10 years. Another early photo shows a beautiful mosaic of 2 nebulae, made from 678 individual images taken over just 7 hours. A single shot might show these nebulae faintly, but combining hundreds of pictures makes the dust and clouds much clearer. At the center is the Lagoon Nebula, or Messier 8, which is about 5,200 light-years away from Earth. This pink kidney-shaped nebula is one of the few star-forming nebulae visible to the naked eye, though only faintly if you're in the middle northern parts of Earth. Through a telescope or binoculars, it would look like a grayish patch of clouds. That's because our eyes can only see certain kinds of light, but the Rubin Observatory can detect a wider range. The extra types of light can be shown in the image using different colors. For example, in this picture, infrared light, which comes from cooler objects, is shown in red, while warmer ultraviolet light is shown in blue. For comparison, here's an optical photo of the Lagoon Nebula taken by NASA's Hubble Space Telescope in 2018. The Hubble image shows amazing detail and also uses color to represent things our eyes can't normally see. It zooms in very close, only about 4 light-years across. In contrast, the Rubin Observatory gives a much wider view of the Lagoon Nebula. The difference is striking. The nebula is about 55 light-years wide and 20 light-years tall, but it takes up only a small part of the Rubin image. Why is there such a difference? Hubble is designed to focus on small, specific objects. Its 2.4-meter mirror can capture detailed images with 16.8 megapixels. But the Rubin Observatory has a much larger 8.4-meter mirror and a 3.2 billion pixel camera designed to photograph huge sections of the sky with incredible detail. Hubble's camera can capture an area about 1% the size of the moon's surface in a single shot. But the Rubin Observatory's view is much wider. It can see more than 40 times the moon's surface area all at once. That means Rubin can take pictures covering about 4,000 times more sky than Hubble in one image.
This wide view is a big part of what makes Rubin so special. Let's look again at the Rubin mosaic photo. Thanks to its broad perspective, we can see the entire Lagoon Nebula and several other objects nearby. Near the top, there's a cluster of blue stars called Messier 21. Just below that, you'll find the pink and blue glow of the Trifid Nebula, also known as Messier 20. This nebula is about 9,000 light-years away, located in the Sagittarius constellation, and you can sometimes spot it with a small telescope. Below that is another star cluster called Bochum 14. Near the bottom center of the image, there's a densely packed globular cluster called NGC 6544, which contains tens of thousands of stars. The number of stars and galaxies visible in these photos is amazing, and on the full mosaic, this globular cluster looks like just a tiny dot. But these aren't just beautiful pictures. The Rubin Observatory is already delivering real science. In just 10 hours, it found 2,104 new asteroids in our solar system, including 7 near-Earth asteroids, which don't pose any danger to us, thankfully. For comparison, all other observatories combined discover around 20,000 new asteroids each year. Rubin alone is expected to find millions of new asteroids in its first 2 years. It might also be the best tool yet for spotting visitors from outside our solar system, like Oumuamua or 2I Borisov. Astronomers believe these interstellar objects pass through our inner solar system about once a year, but it's only recently that telescopes like Pan-STARRS 1 and now Rubin can actually detect them. That's not all. The observatory also spotted 46 RR Lyrae stars. These are ancient stars that pulse regularly and help measure distances in space. Over time, Rubin is expected to find up to 100,000 more, some located more than 1 million light-years from Earth. By tracking these stars, Rubin can help astronomers map the outer edges of our Milky Way and learn more about its shape. In just its first year, Rubin will collect more optical data than all other observatories combined throughout history. By the end of the survey, it's expected to gather around 500 petabytes, that's 500,000 terabytes of data, containing billions of objects and trillions of measurements. This will be a treasure trove for scientists. Once testing is finished, Rubin will keep scanning the southern sky over and over, catching brief cosmic events as they happen and creating a 10-year time-lapse of the universe. We don't know about you, but these first images already blew us away, and the full survey hasn't even really started yet. We're so excited to see what's next. See you next time.